Hello students, this is Tausif Snigdho. Welcome to lecture 4 CSE230 Discrete Mathematics. In this lecture, we are going to learn about some combinatorial identities and see their elaboration. We'll know about binomial expansion theorem, see its proof and application, and we'll know about multinomial expansion terms and know how to determine multinomial expansion terms and see some examples. Before we go into our today's topics, let's recall the topics of the previous lecture, lecture 3. At first, we studied sum rule of counting. In sum rule, we knew that if a procedure has to be performed following task 1 or task 2, where there are total n1 ways to perform task 1 and n2 ways to perform task 2, then the whole procedure can be done in total n1 plus n2 ways. How? See, task 1 and task 2 has a relationship that is defined by OR, and as we know, OR refers to addition, so this is why here we got addition sign. We studied product rule, and product rule says that if a procedure has to be accomplished performing both of the tasks T1 and T2, where there are n1 ways to perform T1 and n2 ways to perform T2, then the whole procedure can be done in total n1 into n2 ways. Here T1 and T2 are related with each other by AND, right? And AND refers to multiplication, as we can remember. So this is why we multiplied here. So then we studied permutation. The important portion of permutation is permutation without repetition. In case if there are total n options available and there are total r slots, and if you are asked to arrange r number of elements out of this n, then the total number of permutations will be npr equals to n factorial divided by n minus r factorial. What does it mean? It means you have to arrange r number of elements out of total n number of elements, and the total number of permutations will be n factorial divided by n minus r factorial. And very important feature of permutation is order of the elements always matters in case of permutation. It means order changes, permutation changes. Then we studied circular permutation, and for circular permutation the formula was, if you are asked to arrange n different elements in circular fashion, n different elements, then the total number of permutations will be n minus 1 factorial, right? And we must remember how linear permutation is different than circular permutation. As we can remember that in linear permutation, if there are 6 different slots here, this is called the first slot, this is the last slot, or this is the first one, this is the last one. But in case of circular permutation, can you define which one is first, which one is last? Since there is no such reference point, so for the first element, instead of n ways, there is only one way to put that first element in any of these slots, because all of the positions for the first element is symmetric for the first element. Okay, and at last we studied combination. We know the formula NCR equals to n factorial divided by n minus r factorial into r factorial, right? So it means that in how many ways can you choose r different elements out of n? I repeat, you choose r elements, right? So NCR refers to in how many ways you can choose r different elements out of n, and that is n factorial divided by n minus r factorial into r factorial. And very important feature of combination is the order of the selection. Since combination refers to selection, order of selection doesn't matter in case of combination. This is the basic difference between permutation and combination. And as we can remember, if we have to arrange n different things and k of them are same elements, then in how many ways can we arrange all of those elements? N factorial divided by k factorial. We studied this as well, right? Okay, so in case of today's class, we'll first start our class with a very interesting question. In last class, if you can remember, we saw that 0 factorial equals to 1. So why 0 factorial equals to 1? Let's see. 1 factorial can be written as 1. 2 factorial can be written as 1 into 2. 3 factorial can be written as 1 into 2 into 3. 4 factorial can be written as 1 into 2 into 3 into 4. 5 factorial can be written as 1, 2, 3, 4, 5. Can we rewrite all of these factorials in a different pattern? Let's try. Just close the first portion like this. This is 4 factorial if I'm not wrong, right? This is 4 factorial. So we can write here that this is 4 factorial into 5, right? Okay. If we close this, this is 3 factorial, and we can write here that this is 3 factorial into 4. This is 2 factorial, and it can be written as 2 factorial into 3. This is 1 factorial. This can be written as 1 factorial into 2, right? So we can see here that for 5, here we get 5 into 4 factorial, right? For 4, we get 4 into 3 factorial. So if the number is n plus 1 factorial, what will we write? We'll write that this is equal to 1 into 2 into 3 into 4 into up to n into n plus 1. So we can separate this part, and this is equals to n factorial. So we can write it like n factorial into n plus 1, right? Like this. 5 factorial equals to 5 into 4 factorial, 4 equals to 4 factorial equals to 4 into 3 factorial. Similarly, n plus 1 factorial equals to n plus 1 into n factorial. So this is a very important identity, and we will be needing this identity later. Okay, remember this. Okay, so this is what we get, and we had to determine the value of 0 factorial. How will we determine that? Okay, since 5 factorial equals to 5 into 4 factorial, 4 factorial equals to 4 into 3 factorial, 3 factorial equals to 3 into 2 factorial, 2 factorial equals to 2 into 1 factorial, 1 factorial will be equal to 1 into 0 factorial, right? Okay, yes. So we can write from this that 1 equals to 0 factorial into 1. That means 0 factorial equals to 1 by 1 equals to 1. So here we get 0 factorial equals to 1, right? So I think we can remember this, how we get 0 factorial equals to 1. Okay, let's move to the next problem. Here, this is the first one, this is the second one. What is the value of NCN? Okay, NCN equals to what? You can answer it easily, because you'll see that NCR equals to n factorial divided by n minus r factorial into r factorial. So according to the formula, we get NCN equals to n factorial n minus n factorial to r factorial, sorry, n factorial, because we replace this r with n, right? So it will happen similarly here. N factorial equals to 0 factorial into n factorial, right? And it will eventually get, will get what? 1. Why? Because this 0 factorial equals to 1, and both of them will cancel each other. So NCN equals to 1. Right? Can we explain this statement using an example? Yes. How? For example, say there are 4 balls marked by 4 different letters A, B, C, D. If I ask you to choose all of the 4 balls and say, in how many ways can you choose all of the 4 balls? You would say, since here total number of balls equals to 4, and since here I have to pick 4, so the total number of ways will be 4C4, in which I can choose 4 balls out of 4. And now just forget about these algebraic calculations. Apply your common sense. If we have to pick all of the 4 balls, in how many ways can it be done? You'll have to pick all of them, right? You'll have to pick all of these 4 balls, and only if you pick all of them, then 4 of the balls will be chosen. So there is only one way that can satisfy the condition. I'll have to pick all of the 4 balls, and I picked that. This is the only way that satisfies the condition. So 4C4 equals to 1. Similarly, if you are given n different elements, and if you are asked to take n, there is only one way, that you'll have to pick all of those elements. So NCN equals to 1. This is the example or practical example of NCN equals to 1. Now NC0 equals to what? This is also easy. From the formula, NC0 equals to n factorial divided by n minus 0 factorial. 0 factorial, as we know that n factorial is 0 factorial, 0 factorial is to 1, so it means 1. That means NC0 equals to 1. So out of n different elements, you can choose 0 elements in only one way. How? You will have to eliminate all of the elements. That is the only way you can choose 0 element out of this n. This is the explanation of NC0 Bn1. Okay, let's move to the next problem. Here NCR equals to NCn minus R. You'll have to prove that, right? Okay, prove that. And you must remember this as well. This is a very important identity. Left hand side equals to NCR. That is according to the formula n factorial divided by n minus r factorial into r factorial, right? As simple as that. And what is the right hand side here? Right hand side equals to, NCn minus r. That is, r is replaced by n minus r. So we'll apply the same formula, but we'll replace r with n minus r like this. Factorial, careful about this permutation, factorial sign. N minus r factorial. This is outside the bracket, right? Okay, then this is equal to n factorial. This is r factorial, and n minus r factorial. So can we see that this is equal, and the lower part or denominator is also the same. So this is equal to left hand side of the statement. So we proved it, right? Yeah, NCR equals to NCn minus r. So can you feel this statement? Can you just feel it? Okay, to feel this statement, we can have an example. How? Okay. The example can be, how many ways can you invite r classmates of yours among total n classmates? Simply, you will invite r of your classmates in your birthday out of n. So how will you do that? Your answer is very simple, NCR, right? Okay, this is very easy. But can you just understand that when you are choosing r classmates, you are eliminating n minus r of your classmates, right? This is the r students whom you have invited to your house, and this is the n minus r students whom you have eliminated, right? So this question can also be asked in another way. How many ways can you eliminate n minus r classmates among total n classmates from your invitation list? Isn't it the same? Each time you pick r students, you are eliminating n minus r students, right? So if you are asked that you have to eliminate n minus r students or r classmates, what will you do? You'll say that I'll just choose n minus r out of total n elements and then eliminate them. So how many ways can it be done? NCn minus r ways. Okay, so as we saw there, NCR equals to NCn minus r. We got here NCR, here we got NCn minus r. What does it mean? Okay, let's have an example. Say there are total n equals to 10 students in your class, and you will invite only 3 of them, right? Can you see that if you choose these 3, by your selection, there is automatically 7 other students eliminated. So for each of the selection, if you select R students here, there are a lot of selections. If you select R students, n minus R students are automatically deselected, right? So for each of the selection, there must be a corresponding deselection. So can we just say that for if there are total NCR ways to select R people, there must be NC n minus R ways to deselect n minus R people. So they will be both same. This is how you can fill this statement. This was an extra example. Okay, now at last, can you prove this statement? Okay, we'll try to prove it. This is another problem and we'll have to do some algebra here. Left hand side equals to n minus 1 CR minus 1 plus n minus 1 CR. So we can write it like this: n minus 1 factorial divided by n minus 1 minus R minus 1 factorial into R minus 1 factorial plus n minus 1 factorial divided by n minus 1 minus R factorial into R factorial, right? So we can simplify it like this: n minus 1 factorial, and this will be n minus R factorial. This is n minus R, right? And the remaining one is R minus 1 factorial. And here n minus 1 factorial, we get n minus R minus 1 factorial R factorial. Okay, here we should remember something. At first we got that n plus 1 factorial equals to n plus 1 into n factorial. Can you remember that? So n factorial into n plus 1 equals to n plus 1 factorial, right? So here we can have something common here. N minus 1 factorial is common to both of these terms. And see here that, can we write this using this formula, n minus R factorial? Yes, we can write this using this formula. We can write it like this: n minus R minus 1 factorial, like here n, into n minus R, okay? And here R minus 1 factorial will remain the same. N minus 1 factorial is like this, and n minus R minus 1 factorial remains the same. And can we write R factorial using this? Yes, we can write it like this: R minus 1 factorial into R. Remember about this identity, we have used this identity here and here in this case and this case. Okay, so now we get a few terms common here. See here that n minus 1 factorial, this is common as well, and this term is also common as well. So n minus R minus 1 factorial and R minus 1 factorial, all of the three terms are common. So what do we get? 1 divided by n minus R plus 1 divided by R, right? Okay, so what do you get now? Now we get n minus 1 factorial, n minus R minus 1 factorial, R minus 1 factorial, and we get n minus R into R, here R plus n minus R. So at last we get n minus 1 factorial, n minus R minus 1 factorial. This n minus R will be multiplied with this. I want to multiply with this, and then R minus 1 factorial is multiplied with R, and here is n, right? So eventually what we get is n minus 1 factorial into n. This is equals to n factorial. This is equals to n minus r factorial, and this is equal to r factorial. So it is something equal to n c r. See? Okay. So now elaboration of previous identity using the example. This is your duty to determine or figure out that, you'll have to figure out an example of this identity, real life example. That's all from this session.